Hi everyone, welcome back to this channel. This is how Zig improved C. So this is a remake of a previous video because there are a few errors I made. Apologies for that in the previous video. Here are some better examples, I hope. So what is Zig? Zig is a systems programming language which attempts to fix the problems with C, mostly to make it more robust, safe and reliable. So here we have the first example, which is simply just going out of the bounds of the array. So a notorious problem in C is that you can access out of the bounds of arrays and it will not stop you. It will allow you to do it. Sometimes it results in a seg fault. Sometimes you can access a function somewhere else that you shouldn't, and it could be a security risk in lots of areas. So here obviously, yeah, we're going out of the bounds of the array because it should be 0 to 9. So there are other ways to actually catch this in C. You could use clang, which is a static analyzer for C, but by default it will not actually check for you. If we run this, it actually shows value at 10, 0, which we shouldn't be able to access. It shouldn't allow us to do this. Of course, you could be very thorough. For example, you could do something like this. So you could say array size 10, and then set everything to array size, and then simply have an if the index is in range, then print it. If it's not, then say it's in range and say the bounds. You're not forced to do it, and you have to kind of be thorough yourself. So let's look at the Zig implementation of this. Basically, this is the same. We have a few things that are different. So when we declare an array, we have to say undefined at the start, which is the way to say it's not set to anything, and then we set it afterwards. So when we use a for loop, it actually uses an iterator. And the I value here, the I variable, is actually a usize. And a usize is a pointer-sized variable, which is either, I think it's like 64 bits. It depends on your operating system which size it will be. So we have to int cast it because we're putting, and a U64 won't fit directly into an I32. So yeah, and a usize is generally, it's U64 normally. Depends on the operating system. And then, yeah, so when we compile this, we get a compile error. So it tells you index 10 outside the bounds of the array. If it's known at compile time. So if Zig knows at compile time that something is outside the bounds of the array, it will tell you. Otherwise, it will panic at runtime and won't allow you to do it. So if all else fails and you access outside the bounds of the array, it will just panic and stop the program. So next we have the problem of null pointers in C. So obviously this will crash if you run this because you can't access the memory address of null, of nothing, so you can't do this. So to make this safer, you got to do something like this. You got to say if pointer equals null, pointer is null, can't dereference it, else print what's out the pointer. You kind of need to do this yourself. There are tools you can use in Clang that allow you to find these. You have to kind of go out your way to actually do this. Let's see how Zig fixes this problem. So here we have, so to actually make a variable null, you have to make what's called an optional using this syntax. So you put a question mark before it, and that makes it an optional. And an optional is something that could be null. You can't, by default, make a variable null. You have to make it an optional. On the next line, we have this kind of very weird syntax, which is dot question mark dot star, which it's an optional. So to directly actually access an optional, you need to unwrap it using dot question mark, which unwraps the optional, and then you dot star, which unwraps the pointer, gets the value at the address because it's a pointer. The problem with doing this is this will still crash because, well, it will still give you a compile error because it's null and you can't unwrap a null pointer. So what you have to do is do something like this. So you have to do, here we have just an if statement and else. So this if basically is if the pointer isn't null, then store it in this value and then print it. And it will create a non-optional variable. Otherwise print it. Otherwise print pointer is null, and this prints pointer is null because obviously it's null. Next, let's look at some errors. So imagine we want to parse these into integers. This is the C code, so we're just going to put these into a function called parse input. Here's the function. So this is without any error checking at all. So we're using strtol, which is part of the stdlib.h library. It's a bit complicated, this, honestly, but basically what it's doing is it's taking the char pointer and it's going through each character, and then we put in decimal is like you put in the type. So it's like it could be a different type of integer. It could be like hexadecimal, but we want decimal, so I made a constant called decimal to make it clear. But imagine you want to know, what are the errors for this? You have to do a lot of research, and you have to understand, well, what does strtol, what does that do? Look up the errors online, find out what could happen. And this is what I came up with doing that. A very long list, so we have a lot of header files at the top, error number, limit, string, and error number is a macro, I believe. And this is just a way to detect errors. So the first one, eRange, this basically is an error that will be flagged if there's an overflow in some way. We check using limits.h if it's an overflow or an underflow. Then the next one is if the last character isn't null. So basically it will go through and then you find the null terminator as a string. Every string has a null terminator. Every const jar pointer has a null terminator. If you don't find that, then there was an invalid character because it stopped somewhere. And if the error code isn't 0, then print the error code, otherwise print the value. It's quite long-winded to do all this. Let's look at the Zig implementation. So yeah, the main function is basically the same. There's almost no difference. So here is quite a lot less code. So here we're importing FMT. FMT is for formatting strings, and you use it to parse. And then we import parseInt error because we need the error. It's just an easy way to write error instead of, I could write FMT dot, I just didn't want to write that. So at the top of the function we have parsed value equals parseInt error exclamation mark I32, which basically means this is a error union, meaning it could be an error or it could be a value. And if there's it could be either, and you need to check if it's one or the other. And then we put in, because parseInt can return a parseInt error or an I32. So this, we need to actually check if it's that. And now the way we check that is by wrapping it in an if statement. So if the result wasn't an error, then we put it in the temp value, the temp variable value, and print it. If it was an error with else, then we put it in error, EERR, and then print that. And whatever the error is, it will print that. So we don't need if statements for each case. So just to show the outputs are basically the same. I mean, I added a bit more information with the Zig code, but they're basically doing the same. Say you want to know the possible errors from parsing an integer. There's an inbuilt mechanic for Zig for doing that. Simply what you do is you catch directly, and catch is a way to give a default value to something, and then we switch on the error, and it will give us a list of everything that could happen. So it could give us an error overflow or an invalid character. Those are the two options when you parse an integer. So I don't need to look on the internet. The language tells me. Lastly, we have probably the most annoying thing about C. Say, for example, we want to call this function, right? This is going to give us an error. Why? Because function's underneath main. The way C works is it goes line by line, and then looks for a symbol and looks above. It doesn't look below. If you want it to work, you've got to do something like this. You've got to put a function declaration above it, and then it will work, or you move the function above it, like that, which is very annoying, honestly. I just find this very tedious, and sometimes I forget, and sometimes like you can have functions that kind of reference each other. You can't put them both, you've got to declare it at the top. It's just kind of annoying. Next we have header files. Imagine we want to use, say we want to use math.c in main here. So we can't use it directly like this. It will give us an error. Well, it won't give us an error directly. It will give us a compile error if we run this. So what we need to do is create a header file. So we need to copy all these and declare them, and then include them in main.c. So it's quite annoying. So in the top we have math.h. We copied all of the function and declared them, and then we have to include math.h in main.c, and then we can call them. The problem with this is, let's say if we have another file, we've got to include math.h, and we say if we want to include all those functions in somewhere else, you've got to have another header file and then have all those functions copied. And let's say you have 100 functions in a library, you have to copy each one and put them in a header file. Tedious as hell. Why do we need to do this? Let's see how Zig does it. It's basically the same, but there's no header file. So the functions are the same, but at the top here we have const math equals at import math.zig. So we just import everything, and then we use it as if it's like and we use it basically like a class. So you say math.add, math.multiply, math.subtract. I don't need to declare every function in this. The only thing you really need to do is make it public. So if you make it public, you can use it anywhere. If you don't put pub at the start, then you can't use it, and it will give you an error if you try to compile it. And that's basically it. So no header files, they're gone. Here's a list of some of the improvements in Zig over C. All variables must be used, so Zig will actually, the compiler will check if you're using a variable or not. In debug mode, that is. So if you're in debug mode, it will check. Otherwise, if you're in release mode, it won't. Or release safe, it will, but the other releases it won't. So it basically wants to check: are you using every variable? Why make it otherwise? So handling errors is mandatory and streamlined. Like I showed you with the C version, I had to put loads of ifs. I had to research what the errors were. In Zig, you can simply just say else error and then print it, and it just tells you the error. And it's also mandatory. You can't ignore the errors like you can in C. So optionals, variables that can be null, can't be used directly, so you got to wrap them in if statements. Otherwise, it will give you a compile error if you try to unwrap something that's null. So index checking at compile time, not possible to access memory outside the bounds of the array. So you can do this in C if you use some static analyzers like Clang or something like this. But in Zig, it's built into the language, and you don't need to install anything else. There are different allocators. So in C, you basically have malloc, or you can make custom allocators if you want. But Zig comes with multiple for different types. You have allocators that don't allocate on the heap. You have allocators that are used for testing. You have arena allocator that can deallocate everything all at once. So different tools for different situations. Easier to install and run. It's actually very annoying to install C on Windows for some reason, even though C is written in Windows. No macros. Values can be worked out at compile time. So in Zig, you have comp time instead of macros. And macros, yeah, just a big problem in C. And then no header files. So to use other files, just simply import them. So if anyone wants to learn Zig, I do have a tutorial series on my channel. But Zig obviously isn't at 1.0 yet, so things are subject to change. But see you guys next time.